You've got 16, 32, or even 64 gigabytes of RAM installed in your system, yet somehow your games still behave like they're starving for memory. It doesn't make sense at first glance. You launch a game, everything looks fine, and then suddenly your FPS tanks the moment you Alt-Tab. Textures pop in late, menus lag, or you get random stutters whenever the world loads a new area. It's frustrating because on paper, you have more than enough memory to avoid all of this. So why does your PC act like it's running on budget hardware? The truth is simple, and honestly, a bit annoying. Windows, along with many modern games, does not automatically use your RAM efficiently. In fact, the system often leaves huge amounts of memory sitting idle, doing absolutely nothing, while shifting extra work onto your CPU or storage drive. When that happens, bottlenecks appear everywhere. But today, we're going to fix that. I'm going to walk you through several hidden, practical, and extremely effective tweaks that unlock your RAM's full potential, reduce memory-related slowdowns, and stop your PC from behaving like you only have 8 gigabytes installed.
Step 1. Verify RAM speed and dual-channel configuration. Before diving into Windows adjustments, you need to confirm your hardware isn't already limiting performance. You'd be shocked how many people spend hours tuning Windows, cleaning drives, reinstalling games, only to discover the real problem was their RAM setup the entire time. A misconfigured RAM kit can cost you 30 to 40% of your potential gaming performance before the game even launches. That's why the very first step is to check your RAM speed and channel configuration. Download and open CPU-Z. It's free, lightweight, and extremely accurate. In the Memory tab, look for 2 key details. Channel. This must say dual. If it says single, your memory bandwidth is effectively cut in half. DRAM frequency. Multiply the value you see by 2, since DDR means double data rate. So if CPU-Z shows 1600 MHz, your RAM is actually running at 3200 MHz. Why this matters? Single channel mode drastically reduces the amount of data that can travel between your RAM and CPU at any given moment. Since modern game engines rely on rapid access to memory for streaming assets, handling large worlds, and running intensive background operations, bandwidth limitations cripple performance. Step 2. Disable sysmain and prefetch. Windows has a service called sysmain, formerly superfetch, that attempts to predict what apps you'll open and preload them into memory. While it sounds helpful on paper, it's terrible for gaming rigs. Sysmain constantly moves data into and out of RAM and heavily accesses your SSD or HDD in the background. These background tasks steal resources that should be dedicated to your game. To disable it, press Win+R, type services.msc, scroll to Sysmain, right-click, Properties, set Startup Type to Disabled, click Stop. Pro tip: if you rarely use Windows built-in file search, you can also disable Windows Search, which aggressively indexes your drive and wastes both RAM and I/O cycles. Turning off these services keeps your system lean, prevents background RAM bloat, and ensures your memory and storage bandwidth stay available for what actually matters, your gameplay.
Step 3. Set a stable page file. Even with 16, 32, or 64 gigabytes of RAM, Windows still relies on the page file, a hidden system swap file stored on your drive. When memory gets tight, Windows offloads data into that file. The issue is that when Windows manages the page file automatically, it resizes it dynamically. During gameplay, this resizing can cause hitches, micro-stutters, and even full crashes. To fix it, open Advanced System Settings. Under Performance, click Settings. Go to the Advanced tab. Under Virtual Memory, click Change. Uncheck
automatically manage. Select your C drive, choose Custom Size. Use these values. Initial size is 1.5 times your RAM. Maximum size is 2 times your RAM. Restart after applying. A stable page file means no mid-game resizing, no lag spikes, and fewer memory-related crashes.
Step 4. Enable large system cache. Windows tries to balance RAM usage between active programs and system caching. This works fine for general tasks, but for open-world games and titles with heavy asset streaming, Windows does not allocate RAM aggressively enough for caching. That's where the hidden large system cache registry tweak comes in. Enabling it allows Windows to reserve more RAM for caching game data, reducing microstutters when loading textures, models, or new map regions. To enable it, press Win+R, type regedit, navigate to HKey local machine /system /current control set /control /session manager /memory management. Locate large system cache. If missing, create a new 32-bit D word. Set the value to 1. Restart. Only use this if you have 16 gigabytes or more.
Step 5. Fix VRAM overflow behavior. When your GPU runs out of VRAM, games don't always fall back to system RAM correctly. Instead, they often dump data onto your storage drive, which is far slower and leads to major stutters. To fix this, enable Prefer External Manifest, DW32-bit, set to 1. This helps DirectX handle VRAM overflow by pulling into RAM instead of hammering your SSD. Step 6. Remove background RAM hogs. Many apps silently consume huge amounts of RAM even when minimized. Open Task Manager, sort by memory, and close Discord overlays, RGB control apps, idle launchers, unused browser tabs, screen recorders, widgets, or background toolbars. Bonus: in Discord, go to Settings, Advanced, and disable hardware acceleration to save RAM and GPU cycles. Step 7. Use ISLC, Intelligent Standby List Cleaner. Windows keeps standby memory filled with cached applications. When your game needs RAM fast, Windows doesn't always clear this memory quickly enough, causing sudden drops in performance. ISLC fixes this automatically. Once installed, set Free Memory is lower than 1024 megabytes. Enable Start Minimized. Enable Auto Start. This ensures games always have the RAM they need during heavy loading moments. Step 8. Check Windows memory compression. Windows compresses memory to store more data in RAM. While it saves space, it also increases latency, which is bad for smooth gameplay. To check, open PowerShell admin. Type get MMA agent. If memory compression is enabled, disable it. Disable MMA agent -MC. Restart afterward. Systems with 16 gigabytes plus almost always benefit from turning memory compression off. And that's how you fix games that don't properly use your RAM. We hit every layer of the problem: hardware configuration, dual channel and XMP, sysmain and Windows RAM wasting services, page file stability and optimization, Windows caching adjustments, VRAM overflow handling, standby memory cleanup, memory compression control, and game-side RAM usage. With these adjustments in place, your system can finally use the memory you paid for. That means smoother gameplay, fewer stutters,
faster loading, and a system that actually behaves like it has 16, 32, or 64 gigabytes of RAM. If this helped, hit that like button, subscribe for more performance optimization guides, and drop a comment with your before and after results. Enjoy the smoother experience, and stop letting Windows waste your memory.